Hey everyone, sorry I'm not there today, but I wanted to go over the notes and warm up for today so that we don't fall behind. So let's start with our warm up. Today is Tuesday, so we're going to be looking at those Tuesday problems. First one says, if QS bisects the angle PQT, so here's PQT, and QS is a bisector, that means that it's cutting it exactly in half. So the left side is equal to the right side. So those round things mean that they're equal. Next part says the measure of PQS is 12x minus 2. So that's here on the left. And then the measure of SQT is 10x plus 14. Find the measure of SQT. Okay, so before we can find the measurement of anything, we need to find out what x is equal to. And since I know that both of these sides are congruent, we can start by setting those expressions equal to each other. Okay, I'm going to do a line down the middle to keep everything organized. Just like yesterday's warm-up, we're doing Don't Call Me After Midnight. Those are the steps for always solving a multi-step equation. D stands for distribute, but that only applies if you have parentheses, which we don't. So I'm going to cross that one out. C stands for combine like terms. If I look at the left, one has an x and one doesn't. And then if I look at the right, one has an x, one doesn't. So that one also doesn't really apply to us. The first one that actually does apply to us is M for move the variable. Variable is letter. And see how there's x's on both sides? So we want to move one of them. I like to move the smaller one. So 10 is smaller than 12. I'm going to move the 10. And we move it by doing opposite. Since this is a positive 10, we're going to subtract, which leaves us with 12 minus 10 is 2x. Let's bring down our minus 2. This cancels, and I still have my 14. Okay, so that is a check. Then A stands for add or subtract. So it's never both. It's only going to be one. And in this case, we are going to add 2 to both sides. Okay, so it cancels from the left. And now I have 2x equals 16. And then last step is to either multiply or divide. And same as before, it's only ever one or the other. And 90% of the time, it's going to be divide. So when I divide both sides by 2, I get x equals 8. Okay, now that I know that x equals 8, I'm going to plug it into the one I'm trying to find. So we're trying to find SQT. So we're going to plug it into this one here. SQT is equal to 10 times 8 plus 14. So if you do that math, that's going to come out to 94. So the measure of angle SQT is equal to 94 degrees. Okay, so we did all of our equation right, and I know that that's the right answer. But if you look at the picture, it doesn't look right. Like these don't look like right angles. So you can't really trust the picture that much. Always go by your math. Okay, and then question number 2, going back to some midpoint stuff from the beginning of this unit. Find the coordinates of point B if M is at 1, -1. So I'm going to go ahead and graph that point. 1, -1 is right here. That's M. And that point is the midpoint of segment AB, where A is at -2, 4. So -2, 4 is right here. So that's A. So there's a segment that connects those two. So A to M. But then they said that M is the midpoint. So that means that this line keeps going. So we want to know where exactly does the line stop if M is the midpoint. So we need to find out exactly how far away A and M are. We were doing this with the midpoint formula before, and you can still do that, but I wanted to show you on the graph how it's a lot easier. You just have to figure out how far away they are from each other, almost like slope. Like you are going to count rise over run. So looking at my y's, I'm going down 1, 2, 3, 4, 5. So that's -5. And then going to the right, it's 1, 2, 3. Now that's the midpoint. So if I want to make sure that both sides are exactly the same, I need to do that same pattern again. So down 5, 1, 2, 3, 4, 5, and then across 3, 1, 2, 3. So you could even see how my dotted line kind of made it there. That's where the end of the segment has to be if we want both sides to be equal. So that's where point B needs to be. So B is at the coordinate 4, comma, -6. Okay, and like we've been doing, please make sure that you put this green warm-up sheet somewhere that you're not going to lose it. We do need it for tomorrow and the day after. Okay, now I want to go to our booklet. So this is the second half of Unit 1. It just had a white paper in the front. Make sure you're looking at the packet that says Part 2. And I want y'all to open up to the next page that we haven't filled out yet. So the page that says Angle Relationships Notes. Okay, so yesterday and on Friday, we did some angle vocabulary, but we were looking at how like one angle is related to itself. So we have measurements like obtuse and acute, and then we also had vocabulary words like perpendicular. But today we have angle relationships. So meaning like if we have two or more angles, how do they relate to each other? Okay, so we're going to get some definition out of the way here. First one is vertical angles. It's not exactly what it sounds like. So usually when we think of verticals, we think up and down. That's not what happens with vertical angles. So for these, we call vertical angles two angles that are across from each other on intersecting lines. And these vertical angles are always, always, always congruent. And remember our symbol for congruent, equal sign with a little squiggle on top. So looking at that example that's right next to this, angle 1 is across from angle 3. So see how I'm doing those marks there? Angle 1 is across from angle 3. That means that those are vertical angles and they are congruent. So I'm going to write angle 1 is congruent to angle 3. Okay, but that's not the only set that's in this picture. So you could also do the same thing with angle 2 and angle 4. They're across from each other and they're congruent. So angle 2 is congruent to angle 4. Those are vertical angles. Let me erase these little marks. I'm going to do it with my highlighter so we can see it better. So 1 is across from 3 and 2 is across from 4. That's what we're looking at when we're looking at verticals. Okay, the next word, adjacent angles. So just in real life, if you know what adjacent means just like next to something. Somebody lives adjacent to the school, things like that. So adjacent angles are two angles that are next to each other. And these angles are always going to share a common side. So see how in that picture, angle 1 and angle 2 are next to each other, but also they both have this same side, like they both have that included. So adjacent angles just means next to each other. Complementary angles. So this is where we have to start remembering some numbers. So looking at that picture, and then you see that little square, that means that it's a right angle. So complementary angles are any two angles whose sum is equal to 90 degrees. Remember, sum means add. So if I were to add the measurements of those two angles, it would equal to 90. That's what makes them complementary. So I'm even going to write that here. The measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. Okay, supplementary, very similar, but it's just a different number. Supplementary is any two angles whose sum is 180 degrees. So if you look at that picture, the example that they give us is an angle that's 52 degrees and an angle that's 128. But if you add those up, you'll see that that actually comes out to 180. So that means that those two angles are supplementary. So in the past, I've seen students get complementary and supplementary confused. What I do when I was learning these is if you go alphabetical, C comes before S. So that means mathematically 90 comes before 180. So that's just the way I remember. Okay, and then the last relationship we're looking at is something called a linear pair, and it's exactly what it sounds like. Linear sounds like line. So a linear pair is two angles that form a line. But because they form a line, that means that they are adjacent. They are next to each other, right? And they are supplementary, meaning if I were to add them up, it's going to equal 180 degrees. So the measure of angle 1 plus the measure of angle 2 equals 180. Okay, so those are all our pairs that we need to know. So the little table below these vocabulary words is just, are we able to identify these types of angles when we see them? Okay, so we have 6 examples. Let's look at example number 1. We're going to check anything that applies. So it doesn't always have to be just one at a time. It might be more than one. Okay, and I like to color code or do markings or something. So here's angle 1, and then here's angle 2. So how are they related to each other? So vertical means, are they across from each other? Well, yes, they are. They're opposite, so they are vertical angles. Are they adjacent? Adjacent would be next to each other, so like here and here, but it's not that. Or I could do this. So it's not adjacent. Complementary and supplementary both have to do with a number, so either 90 or 180. And none of these have any markings about their measurement, so I couldn't do any of those. And then linear pair would be like if they made a straight line, but they don't. So the only one that applies here is vertical. Okay, number 2, next to this, we're looking at angle 1 and angle 2. So they're definitely not vertical because then they would have been across. Are they adjacent? Well, yes, they are because they're right next to each other. Adjacent means next to each other. Are they complementary? So complementary is 90 and supplementary is 180. Do we know if they make up any of those measurements? So in that picture, you see how we have that little square? So I know that this side is 90, but what about this other side? Does that make 90 as well? So the answer is yes, it does. So because the blue and the green together make up that little square, yes, they are complementary. But they're neither of the other two things, because if they already equal 90, there's no way that they can do 180, and then they're not making a straight line. We're only looking at those two. Okay, now let's look at number 3. Okay, so here's angle 1, and then here's angle 2. They're not vertical, because verticals would be opposite. Yes, they are adjacent, because they're right next to each other. Complementary means that they equal 190, but this is obviously not 90 because 90 would have had a little square. Are they supplementary? Yes, they are, because if it's a straight line like that, we know that that equals 180. And then that kind of answers the question for the last one. They are a linear pair because together they make a line. Number 4, so angle 1 and angle 2. So I have no markings as far as measurements go, so I really can't say any of the bottom 3. It might be one of the first 2, and they are definitely not vertical, so the only thing left is adjacent. They are next to each other. Okay, number 5. So on this one, you have to pay special close attention to those markings. I know that this part means 90. I know that these little round things means that each side is equal. But we are looking at angle 1 and angle 2, specifically those two. So are they vertical? So if you only look at these two lines, see how it kind of creates an X? And then these two angles are across from each other. So yes, they are vertical. They're not adjacent because they're not next to each other. Are they complementary? Is there any way of knowing if these two angles added together equals 90? So I know that this part is 90, which kind of means that all of these are 90. I'm going to do a little square right here, another square here, and another square here. So each little quadrant is 90 degrees. But then you see these markings here with the little line. That means that each side of this is exactly in half. So half of 90 is 45. So this has to be 45. And then since vertical angles are congruent, this is always 45 as well. So see how they're the same? They're across from each other. And if I added those two together, 45 plus 45, that does equal 90. So yes, they are complementary. Okay, they're not supplementary, and they also don't make a line. So it's only those two. They're vertical and they're complementary. Okay, and then the last one, number 6. Here's angle 1 up top, and then angle 2 at the bottom. I could tell right away that they're vertical because they are across from each other. So that means that they're not adjacent. They're not a linear pair because it doesn't make a line. They're not complementary. So the only last one is, are they complementary? Like, do they equal 90 degrees? Well, I think they're 90 degrees each. So if I have 90 plus 90, that's going to equal 180. So these are supplementary. Okay, so now that we know how to identify them, we want to do math with them. We want to solve equations. We want to do all this stuff. So on the next page, here are some examples. The first little section is going to be pretty simple. So 1 through 9 go really fast. But 10, 11, 12 are going to take some algebra. So these take a few steps. Let's look at the beginning. So number 1 on this side, the first thing I would do is identify what kind of angles we're looking at. So I have 112. And then I have this bottom one that doesn't have a measurement. That's what we're trying to find. But see how these are across from each other? So I know that these are vertical angles. And what I know about vertical angles is that they're equal. So if the top is 112, then the bottom is also 112. Okay, then the second one, this square means that it equals to 90. So these are complementary angles. Complementary. That means that if I were to add them together, it needs to equal 90. So I'm going to do 90 minus 68, and whatever's left over has to be x. So this would be 22. So x equals 22 degrees. Okay, number 3. See how this makes a straight line? So this would be a linear pair. And I know that linear pairs always have a sum of 180. So I'm going to start with 180 and subtract the 124. And whatever we have left has to be x. So this is 56 if I'm doing my math right. So x is equal to 56 degrees. Okay, number 4. This one has 3 letters that they want us to find. So let's see if we can go in order. If I were to try to do x first. So what I'm noticing is that right here makes a straight line. Excuse me. So if it's a straight line, I know that that is equal to 180. So I'm even going to write right here. This is a linear pair. So 180 minus 43 gives me 137. So x is equal to 137 degrees. Okay, the next, where y is at, is across from the 43. So those are vertical angles. I'm just going to write vert to stand for vertical. And vertical angles are congruent. So since it's across, that means that y must be 43 degrees. And then going back to z, z is across from the x, so those have to be equal. So z is 137. Okay, number 5. This one has some weird markings, and I would pay close attention to number 5 because I think that there's one similar to this on the test that we're taking Friday. So 3 different angles. We're going to find all the measurements. And again, I'm going to try to go in order. So the first one that I see is x, and I'm noticing that it kind of makes a straight line. It's next to the 72. So if I wanted to find that, a linear pair always makes 180 degrees. Let's subtract the 72 that we already have. So I get 108. So x is equal to 108 degrees. Okay, then angle y is across from this angle here. Those are vertical angles. So y must be 72 degrees. And then you could also say that this is a line, so that needed to be 180. Okay, and then last up that I have is z. Okay, so x, this part that's here, is a vertical angle to this part. Like if you see these two lines, so this part is equal to this part, but on the bottom, I know that this part is 90. So let's use different colors. So x, which we found out was 108, that's going to be the same here, 108. But if this part is 90, to find over this leftover part, I'm going to do 108 minus 90, which gives me 18. So z must be 18 degrees. Okay, the next 4 don't have any figures. You're going to have to read your problem. So number 6 says that they are vertical angles. And the thing that we know about vertical angles is that they are congruent. So I'm going to do the equal sign with a curve on top. So if they are congruent, that means that they have the same shape, they're both angles, and the same size. So if angle 2 is 105, then the measure of angle 1 has to also be 105. So that one was an easy one. Number 7, A and B are complementary angles. Complementary means that they have a sum of 90 degrees. So if A is 42, how do we find the measure of B? Well, we're going to subtract 90 minus 42, and that gives us 48. So that means that the measure of angle B has to be 48. Okay, P and Q are supplementary angles. Supplementary means 180 degrees. So if Q is 64, find the measure of P. So we're going to start with our 180, and we're going to subtract the 64, and we're going to find out what's left over. And I'm getting 116. So the measure of angle P must be 116. Okay, and number 9 says that 1 and 2 form a linear pair. So linear pairs are supplementary, so this is going to be another one where they're 180. If the measure of angle 1 is 113, let's start with our 180, subtract our 113, and see what we have left. And I'm getting 67. So the measure of angle 2 has to be 67 degrees. Okay, so up to this point, we've just been doing basic math, just like adding and subtracting. The last 3 have a little bit of algebra in them, but all of the same rules are going to apply. So first we need to identify what the relationship is between the two angles that they are talking about. So number 10 says, PQT is 3x plus 47. So PQT is this top part right here. So that's the 3x plus 47. And then SQR, looks like that's the bottom part, is 6x minus 25. So because they're across from each other, I know that these are vertical angles. So if we're going to find the measure of SQR, the first thing we need to do is figure out what is the value of x. Since these are vertical, that means that they're congruent, so I can set them equal to each other. Okay. And then now we solve. I'm going to start by moving the 3x, and I'm going to do that by subtracting. So now I have 47 equals 3x minus 25. Let's add 25 to both sides. And that gives me 72 equals 3x. And then last step is to divide by 3. So I'm going to write it to the side because I'm running out of space. But I am getting 24 equals x. Okay, so I'm more than halfway done, but that's not what they were asking me for. They're asking for the measure of SQR. So now I have to get that 24 and plug it in to the one that was labeled SQR. Okay, so SQR. That's going to be 6 times 24 minus 25. And if you have a calculator handy, you could just type in the whole thing all at once. You don't have to do it in parts. Okay, but I am typing in mine right now. And I am getting 119. So the measure of SQR is 119 degrees. Okay, next one. So some of the vocabulary or notation that we learned on Friday, that little upside down T, that means perpendicular. Perpendicular. And if two lines are perpendicular, that means that when they meet at a 90-degree angle. So AB and CD, here's AB, here's CD. They are letting us know that this is a right angle. Okay, the measure of DCE is 7x plus 2, so DCE is here. And ECB is that small area, that's x plus 8. Find the measure of DCE. Okay, so because they told us this part, the perpendicular part, I know that these two angles equal 90 degrees, so that makes them complementary. That means that when I add them up, so 7x plus 2 plus x plus 8, that needs to equal 90 degrees. Okay, so I'm going to start by combining like terms. These two that I'm circling are both x's, so I can turn that into an 8x. And then 2 plus 8 is 10. Let's subtract 10 from both sides. So now I have 8x equals 80. Last step is divide by 8. So x equals 10. So I got this far, but now they want me to find the measure of DCE. DCE is this one right here. So to find that, it'll be 7 times 10 plus 2. You could type that into the calculator all at once, but I am getting 72. So the measure of angle DCE is 72 degrees. Okay, and then last one that we're doing today. If KNM is 8x minus 5, so KNM is this side over here. And M and J, so M and J, that's this down part here, is 4x minus 19. Find the measure of K and M. So this time around, they're adjacent angles because they're right next to each other. But more importantly, they make a straight line when you put them together. See that blue line that I drew? So this is a linear pair. Linear pairs are supplementary. That means that when I add these two angles together, so 8x minus 5 plus 4x minus 19, this time it's going to equal 180 degrees. And we're going to solve it like we did the one before. We should start by combining our like terms. So that's 12x minus 24 equals 180. Add 24 to both sides. So 12x equals 204. And then we're going to divide by 12. So x equals, let me use my calculator real quick, 17. And now that I know that, they want us to find the measure of K and M, and that was the first one over here. So in order to find that, we're going to do 8 times 17 minus 5. And whatever we get is going to be the measure of K and M. So again, I'm using my calculator. I'm typing this in. I'm getting 131. So 131 degrees. Okay, so I know that was a lot of notes to get through, but this was the last thing that we had to learn. So all of this page that I have on your screen just now, this is all some math practice. This is all algebra practice using the rules. What's more important is that you actually know what the rules are. So you need to know this vocabulary. Okay, guys, once you finish this video, as long as you have everything filled in, that is all that I have for y'all today. So you could use the rest of your time working on anything that you are missing, and just email me if you have any questions.